right, we're going to go ahead and cover Module 3, Homework 1 now. So the first question here says, simplify the following square roots. Now, when we're looking at square roots, before we get into those kinds of questions, square root, the essence of square roots is like, let's say square root of 4. You know that that's 2, but why do you know that it's 2? I mean, because you've been told that, or that you memorized it, or something like that. What makes you understand that the square root of 4 is 2? Well, the thing is, what does square root mean? Square root means you're finding the root of a value that when multiplied squared, when it's squared, okay, it equals the number that's inside of the radical, basically. So if I say 2 squared, that's the same thing as saying 2 times 2, and that equals 4. All this is equal to 4. So when we look at a square root, what we call an index is understood to be 2. And when you deal with that square root of 2, this and the square root of 2, excuse me, of 4, really, square root of 4. But anyway, the square root of 2 raised to the second power, these basically cancel each other. All right? Squares and square roots are opposite of each other. And you're left with the base of 2. So it's the square root, the root of the square root is 2, because of the fact that these basically cancel each other. So when we're looking at, let's say, the square root of 121, then we know that it's the 11. Why do we know it's the 11? It's because 11 squared is 121. And the square knocks out the square root. That square knocks out the square root. So when we look at the square root of 144, the same idea is the square root of 12 squared, and the square root knock each other off, leaving you with 12. So we're looking for that idea of something that is a perfect square. Okay? Perfect squares are important. We should know. I would go ahead, if I was you, and you don't know your perfect squares, you should be able to list them all. I mean, go ahead and start with the square root of 1 is 1. All right, the square root of 4 is 2. The square root of 9 is 3. Continue this on until you get all of your base numbers all the way to 12. All right, you should know them, but if you need them as a reference, just go ahead and write them all down, okay? And then you would have them. I'm listing them as I'm talking to you as quickly as I can, but you get the idea that you can continue this, right? So these are the perfect squares, and that means, again, that these two numbers multiply together that's perfectly the same equals that number. So this goes very quickly when you know your perfect squares. So that's why we get these easy numbers. All right? And then when we look at the square root of, like for number 2, number 2, evaluate the negative of square root of 81, and we're looking at 81 as 9. All right? We just talked about that just a second ago when I was writing it down with everything else. So when we take the square root of 81, it's going to equal negative 9 because we have a negative sign in front of it. So that will equal negative 9. Now, there are times when you have variables involved. So when you have variables involved, you can look at the variables as separate from numbers. So you can look at it this way, okay? Square root of 144, well, we talked about that one already. It's right here, is equal to 12. So then that's 12. But then remember, this is an index 2. That takes away anything that's even like that. So what we do is think about it as if it's these two knock each other off, the square root and the square root. So we're left with just simply t, just the value that we're looking for. So 12t. So we keep the numbers and the letters separate in our minds by doing this concept of separation. All right? Now, like I said, this moves very quickly, and once you get the concept. Now, another thing, and I went over all my perfect squares with you. I didn't do them all the way up to 12, but likewise, you should do that for the perfect cubes as well. So if you do, the cubic root of 1 is 1, the cubic root of 8 is 2. The cubic root of 27 is 3. The cubic root of 64 is 4. The cubic root of 125 is 5. And if you, again, don't know these things, I mean, I know a lot of them, okay? So I can keep on going with this because I've been dealing with this for a while. But if you don't know what your perfect cubes are, then what you can do is simply take the calculator and take 8 raised to the third power equals 512. Write this down for yourself all the way up until you get through all your values. So you keep on going. 729. All right. And then you have 1,000 and so on and so forth. Okay. So you can just go ahead and find the perfect cubes by finding the cube of each of these values. All right. And then that'll give you the numbers that you're looking for. It's good to have it up to 12. Okay. So you have, and I would put this on an index card and put it in front of your, your notebook or whatever, put it on the front page or whatever, and then so you have it there as a reference for you. Because with this process, you're always looking to find your perfect cubes or perfect squares and get them out of the radical system. This is an index of 2. A cubic root is obviously an index of 3. Okay, you notice how I'm using that word index. All right. Now, when you're looking at then the cubic root of 27 over 64 is the same thing as saying the cubic root of 27 over the cubic root of 64. So you can go ahead and separate them, and obviously I've given you the two answers. As I look over here to my right, I can see that the answer then, the cubic root, is 3 over 4. All right, that's what's so beautiful about having this list. All right, it gives you the idea pretty quickly about what it equals. And then, like, look at already number 5. You can see number 5 has a cubic root of 27 and then h to the third power. So we're going to get 3h. And moves so fast when you understand this concept of perfect cubes and perfect squares, that this moves so quickly in that regard. So look at the answer is 3 over 4. And the answer here, again, the cubic root, just like I did here on that one, right here for square root, I look at the cubic root of 27 times the cubic root of h to the third power. And then that's going to give me the 3h for my answer. Okay, because I look up here and I see that that's 27 for that value. Now, of course, note that these two will scratch each other off because they're the same exact value. So that's why we get that. So again, these move very quick, but it's very healthy too. I mean, it's easy to understand. Now, when you're taking the idea of square root values, it has to be the same number multiplied against each other to equal that. Well, when you have the square root of negative, let's say 1, there's no two numbers that can multiply together to create that negative 1 that will be a perfect square. Negative 1 times 1 is negative 1. That's not the same number. That's a 1 and that's a negative 1. So that's where you get to be where it's not real, okay? It does not exist, okay? You get into the complex number system when that happens. This is not now. So whenever you get a number, it doesn't matter how easy that is. I know 49, and you're looking at that. I was like, oh, the minutes is 7, and that's going to be a 4. I got it. Boom, done. Nope, that's not right. All right? You know, even though they are perfect squares, this is negative, so this does not exist. See any? All right? But you can, of course, then, because there's no negative sign in the next one, take the value of the square root of 7, or 49 and get 7, and put 7 over, and then the square root of 16 is 4, so you're going to put 7 over 4, and that would be your answer. Now, please avoid the mistake of putting it back into a square root symbol. Do not do that. I have students who take the square root of the 49 and the 16 and then just leave it in the square root symbol. I'm like, what are you doing? You don't understand what you're doing if you're doing stuff like that. That's annoying when I see that. So whenever there's a negative sign in front of it, by the way, for the next one, it's just simply just going to be negative 7 over 4. So the next one is pretty fast right here. So we have the 7 over 4, and then a negative 7 over 4. Now, they did this on purpose to show you the difference between where negative signs are and where, you can take this, but you can't take that. And then, of course, if you do have a negative sign on the outside, you can do it. I'm going to throw caution in the wind, though. When you're dealing with negative or cubic roots, can you take the cubic root of -1? Well, -1 times -1 times -1, okay, equals -1. So the cubic root of -1 is -1. So it's possible to do it with odd indexes for 3, not even index like 2. So that's something I had to make sure I throw at you, because square roots are even, cubic roots are odd, and that's important for us to understand. Okay, so let's go ahead and move on to the next couple questions. I like this. This is one of my favorite subjects to go over. It's so fast. Once you understand the concept of those perfect squares, like you should understand that this is 7. It moves so fast. 7, 0. You can't do it. Any. So that's question number 7. These move very, very, very fast. So that's why there's so many kinds of questions like this. They're so fast. All right, moving on. Square root of n squared is just n. All right, because again, of what I talked about earlier. Now, next thing I want to talk about in this, because I want to help you understand something, is that there's a couple of different ways you can write this, by the way. Okay? By the way, that's an index 2. You can write this as this, or you can write it as this, or you can write it as this. And I'm going to show you something else. Okay? There are 3 different ways to write that same exact problem, and that is the square root of n squared. And notice this one is the most critical one, is that this is 2 divided by 2 is equal to 1, right? And the reason why I want you to see that one, and all these, yes, while these also cancel each other, this is the one that I wanted you to focus on, because what about if I had n to the 24? You take the square root of it. Well, if I know this right here, this concept happens, then I know that I can take 24 and divide it by 2 and get 12. That's how simple these things move. If this is even, I can simply just divide it by 2 and get my variable out of the radical system. That's going to be important to understand later. So I taught you something in question number 8. Okay. Now, number 9 moves fast as well. So the cubic root of 0 is 0. The cubic root of 125 is 5. The cubic root of 216 is 6. So that's why, again, I told you, come back here and go ahead and do this. You can see it can move very quickly when you take in the cubic root of these systems. So our answers are quickly developed. So the cubic root of 343, see, if you have this, until you get them memorized, the answer is 7. So we got that answer pretty quick. All right. Now the cubic root of 64, see, this is really super fast when you're doing it. This is kind of almost like a cheating thing. Until you're going to get it memorized, you can't have this on your person when you're doing it. So you have to kind of memorize these. But by doing the problems, it helps you memorize it. So the square root or the cubic root of 64 is 4, and then you have a negative sign in front of it, so it's -4. All right, now when you're looking at the cubic root of 216, because it's a cubic root, you can take the negative value, but rather than putting 6, it's going to be -6. So that's interesting. It's a little different. So when the negative sign's on the outside and when it's on the inside, unless it was a double negative, right? Because if it was a negative of a negative thing, it would be -6 times -1, which would be +6. So then if there was a negative sign on the outside, it would be a little different. Okay? So that's that. Now, cubic root of 64 is 4. See, I'm looking at my list here. I'm not doing anything but looking at my list. And then I'm able to generate these answers quickly. So the cubic root of 64 is And then the cubic root of w to the third is simply w, so it's 4w. Now we get into this one right here. The concept I just talked about over here applies to this question right here, 12. Because now the square root of 121 is 11, we know that. And then we go ahead and treat this right here, the square root of p to the 42. I want to treat it like this, though. Okay, I want to treat it like p 42 divided by 2. All right, and then that leaves me with the final answer of 11 p to the 21st power, because 2 goes into 4 2 times, 2 goes into 2 1 time, so we get our answer. All right, and that's what we get, 11p to the 21st power. Now, this, for the next part, that was A, this is B. All right, we have the square root of 36 is 6, and then we can do it mentally now, because I don't have to write it all down like this. This is just for me for teaching you purposes, but 50 divided by 2 is going to give us 25. What's happening? 50 is 25. So we have our answer. See, now, again, when you understand the fundamentals of construction, these answers can pop out at you so fast. So when students are like, man, there's so many questions here, it's important you understand that this should move very, very fast. All right. Now, when you're looking at 13, okay, we're looking at the square root of 5, or excuse me, 25 is 5, g to the 7th, because 14 divided by 2, and then b to the 5th, because 10 divided by 2, and then a to the 4th, because 8 divided by 2, and that's the answer. I'm done with that. All right, so look at, we have the answer. There's nothing to this. So this is going to be 10 UW. Answer, done. Now, the fourth root of 256. Now, I encourage you to take and start now recording all the fourth roots. So this is getting a little absurd. However, let's take a look at something. Now, when we look at 256, all right, there's a couple of different ways you can do this. If you want to, you can actually raise it to the 1/4 power. Look at that. Or now I've just entered it into the calculator as a fraction. I mean, this comes into the next lesson as well. I mean, I'm starting to preemptively structure to that. But we can go ahead and we need that structure. When we look at math, when we see this right here on this particular calculator, we hit math. We hit that. This allows us to change the index of our radical system. So 256. We get 4. All right. I mean, I'm going to be honest. I did know that was 4. I'm going to be honest with you, but I didn't. I don't think any of you in here might have known that. But only because I deal with this all the time. So now we have 15. So we have the fourth root of 256 is going to give us that 4 that we're looking for. But then we look at the z to the 20th. Divided by 4 is going to give us z to the 5th. And then we look at y to the 20th, it's going to be y to the 5th as well. And that's our answer we're looking for that. So that's why it was very important for me to teach you all about this concept about how radical systems look as rational exponential powers. Because now it allows you to do structure changes quickly like this. Okay? Now, again, these are very repetitive. So this is going to be 9RS. This is going to be M10E4. So all I'm doing is taking 20 divided by 2, 8 divided by 2. Very, very quick in its movement. All right, and understanding. Hopefully you're gathering quickly on how this works. Now, trying to evaluate that is going to be for number 18. It's going to be obviously -3 because it's the cubic root. So we have -3 to that. And then we have the cubic root of 16. Okay, again, the cubic root, not cubic root, the quad root. I mean, so it's the fourth root of the cubic root. All right, so we have 4. So again, we can come up here, what about the scaffold? I can hit enter, come back in here and hit delete, delete, and then change it to 16 minutes to equal 2. All right. If you are so interested in fourth root systems, you can just do the whole entire thing all the way to 12 and just do, by the way, like 2 to the fourth power, 3 to the fourth power, um, 4 to the fourth power. Some of these we already know because we've been working with them. But then 5 to the fourth power. If you want to go ahead and write them all down on an index card, you're more than welcome to too, but I'm not inclined to want you to do that. It's not going to be too many questions dealing with the fourth roots of systems. So anyway, we're going to get evaluating for number 19. We're simply just going to put down to -2 because we have a negative sign in front of that. So that's our answer for that one. So again, you might want to do this if you want. It's your prerogative, whatever you want. Because I mean, you're looking at the fourth root of -10,000. By the way, anytime the index is even. So let's write that down. Anytime the index is right here. This is some variable, some letter, some number. I'm going to put C for constant. And this is some variable. I don't even know what number that is. But when the index, I mean, we're going to call it out as b to the power. Let's just put it as the power. All right? When we're dealing with an index that's even, then you're going to go ahead and you cannot take the negative value. Negative, not possible. Negative, I'm going to put negative. Not possible. All right? Not possible. All right, I just put pause. It don't matter. Not possible. Odd, negative, is possible. Okay? So we have that. Okay? Just wanted to make sure that you have that written down somewhere. Okay? So when we're seeing that a number, okay, if it's negative, I'm going to put negative here. If it's negative, then you can't take it. Okay? So that's going to be D and E. It doesn't matter about whether or not you can take that value. So whatever the index is the power of the number. No, this is right here. No, the power has itself its own value system. So here's an example. You have the fourth root of 4 to the fourth power. All right. If that was the case, all right, then this would cancel each other, right? And you get 4. So what is the value of? We talked about it already. The value of 4 to the fourth power, 256. So you would have the fourth root of 256. Then you'd have to change that so it is exactly what you said. Power of the, so is the power of the number under the radical sign. Now, the radical sign, the power is not always the same. It's just sometimes it is. You're going to find out later that these will change, where it'll be, let me see, 4, I gotta do something, 4 to the, if I take the fourth root of this, right, that is actually 4 to the fifth power, by the way. So the thing is that what I could do is say, well, 256 times 4 is the same thing as 1,024. So I can take and break this down to be where it's 4, the fourth root of 4. So that would be the answer we're looking for. That's later, though. I don't want to talk about it right now. But I just want to say that they're not always the same. Although in this case it is, it seems like. But I'm getting, in this concept of conversation, I want to make sure that if the index is even, then you can't take the value of a negative value. You can't. It's not possible for negative numbers to be taken. So you put D and E, and for odd you can. So hopefully I answered that question. But that was a great question. It's like a little. It's more advanced at this moment. Now we're looking at the fifth. Right now we're looking at the fifth root of 243. All right. Now again, since that is odd, we can take the value. Now we look at a calculator and we take the value of the fifth root. So we have the 5 as our index, and then we have 243, and we have 3. Okay, so we can take that, and we get the value of then negative 3. All right. Matter of fact, you can actually even put it in as a negative value here. Like you have it in the question and look at it, it's negative 3. So you can put it in the calculator as such. All right, now that gives us negative 3. Now, when we're looking at question number 22, all right, this is nothing more than just 7 over 2. So these are very repetitive, some of them which could be taken out. I mean, it maybe just helps students to memorize the reason why so many, it helps you memorize these right here. I mean, that's what the whole purpose is for giving you so many, is to help you memorize these things. The ones with the fifth root and the fourth root is to try to get you to understand the conceptual side of what index means, how is that related to negative signs, things like that. That's what that's for. That's the intention, not to give you such a hard number system. Okay, now again, the reason why they're giving you this is to understand that D is 20 over 5. I mean, so you can get 4 really quick. So that moves very, very fast. So you get your answer, you're done. So you have your answer. Now, simplify the radical. Again, you're taking the third root of negative 27 is negative 3. 3 goes into 27 9 times, so C to the 9. And then 3 goes into 24 8 times, so it's going to be B to the 8. And then you're going to go ahead and get 3 goes into 9 3 times, so B to the third power. All right, so then there's your answer. We're done. That's for number 24. Whoops. All right, so I got that one right. I mean, these, like I said, they're beautiful questions. They move so super fast. Now, with this kind of question, you're given a formula of such that says B is equal to this question intimidates a lot of students. But they automatically tell you that it says, what is the maximum safe speed? When looking at this, it says that the highway curve, okay, so it says right here, for this problem, round your answer down. So they're asking you, a highway crew measures the radius of a curvature at an exit ramp on a highway as 640 feet. So this is the value of R. So we had to look for that number. So all we have to do is take, and it says maximum safe speed. We're going to go ahead and just put it into the calculator and see what happens. So square root, so hit the square root symbol, 2.3 times 240. And then we're going to need to round this off, okay? Because the maximum speed you want to go is 38 miles per hour. Okay, so that would be the answer that we're looking for. All right. Now, it does say for this problem, round your answer down to the nearest whole number. So it does tell you that. So we want to go down to 32. All right. It always rounds down the answer, no matter how much it is. If it is 38.9, you still round it down to 38 because don't want to maximize your speed at 40 or 39 or something like that because it would be too fast. So this is a pretty straight answer, pretty easy. You might see that again, perhaps, on a test. Okay? That's word problems. Now 26. So here's student solution for writing 448 as a mixed radical. Step solution 448 as 64 times 7, and then 64 they just automatically took out. However, they should not have just taken it out of the radical, because what is the square root of 64? It's 8, right? So we have an issue with you can't, just once you get a perfect square broken away, doesn't mean you just make the radical just disappear and make it look like this. So the student failed to take the radical of 64, which is 8. So there's the issue. So on step 3, they messed up. Okay. Now, what is the correct solution for this as a mixed radical? So this is the answer we're looking for. As a mixed radical system, we're looking at, because you can't take the square root of 7. So this student already helped us with that. Now, students, like, I want to tell you something. What I tell students when you get in a mixed number, like when you get into a radical system, like the second radical, 440, 448, and you don't come up with a perfect square. What I tell students to take the value, okay, and start dividing it by your perfect squares. For example, 4. Now 4, it can go into it, all right, but we have to think about 4 and then 128. Let's look at 128. Let's just hypothetically divide it by 4 again and see what happens. All right, it looks like it's divisible multiple times by 4. Take 28 and divide it by 4. Okay, look at that. We have now multiple 4s, all right, coming out. Matter of fact, we have 3 4s coming out. Now, some students do it that way, and that's a little long, because then what is 4 times 4 times 4? Okay. Well, I should not do it that way. Excuse me. I should do it this way. The square root of 4 times the square root, this is actually the square root of 64, right? So then this is what we end up doing, is breaking it down to the point where we get to the originating idea of what they came up with in this problem. Now, the thing is that it's not the highest perfect square. So what you do is you take the value 448 and divide it by the highest perfect square, which is 64, and you get 7, and then you take the square root of 64 to give you 8. So that's the best approach to these kinds of things. That's for a deep discussion about breaking down radicals. See, so now when we look at the square root of 18, all right, when we look at the square root of 18, 18 is equivalent of 9 times 2, isn't it? So 9 times 2 is 18. Well, we can't take the square root of both of these. We can only take the square root of 9, and that would be the square root of 9 is 3, and we leave whatever we can into the radical system. So we're going to go ahead and leave it as a 2 in here. So there's our answer for that. Now, when we look at the cubic roots, of this value, a student starts getting intimidated by this very quickly. What I tell students to do is don't get frustrated. Just take the value of 6250 and start dividing it by our perfect cube, which is, I'm going to divide it by 125 because it ends in 250. So I figured it probably is divisible by 125, and it is. And the perfect cube of 125 is 5. So what we end up with is 125 times 50 is the value of 6250. So then that means I could take out 5, because that's what the cubic root of 125 is, and I leave 50 inside. side because 50 is nothing more than 5 times 10, which is 5 times 2, but there's no perfect cubes in any of that. Okay, there's no perfect cube in that. So we're not worrying about it. So there's our answer is this. And we're done. And by the way, prime factorization trees is how you get to find out all the parts that make up that number as well. But that's time consuming. I like giving you the strategy of dividing by perfect cubes, dividing by perfect squares, trying to attempt to go after the highest perfect square when you're doing it. All right. So that's the strategies for homework 1 of module 3.